we will discuss menu-driven animated flag using the Bezier curve. In this, there are three parts are there. First, you have to understand how a Bezier curve is drawn with given control points. Second thing, how the flag is drawn with the Bezier curve. Then, how the flag can be animated. And next, how the menu is being created. Then in this, I have given two options in the menu. One is a with animations, another is without animations. And first, we have to understand what is a Bezier curve, and that I have discussed in my previous videos, and you can refer to that. But briefly, I'll discuss the Bezier equations and how a Bezier curve is drawn. First, you come to the Bezier equation. Bezier equation, this is the PU, this is the point on the curve, and that point of the curve will be determined by these equations. And that equation you can divide into two parts. One is a, you can say, Bezier blending functions, that another is the control points coordinates. And another, then Bezier blending functions can be also again can be divided into two parts. One, we can see only the binomial coefficients are there. Other is involving u. And what is u? Already I discussed in my previous. And u you have get different points on the Bezier curve by changing the value of u. Now you can see these Bezier functions I have divided into one. I have given this in binomial coefficients that I have given, and q, this is the part. Therefore, Bezier blending function I have divided into two, and if these Bezier blending functions will be multiplied by corresponding control points coordinate, then we can get the point on the curve, and that is further in details here I am showing here. Therefore, here I am showing that is, you will give you the x coordinate of the point on the Bezier curve. This is the y coordinate of the point on the Bezier curve. This is the z coordinate of the point on the Bezier curve. Now you can see that in this I have a 4 control points, and the expected curve is like this. And in our program also, we'll be taking these control points almost similar to that. And therefore, I've taken here. And from these Bezier curve will be drawn. And after drawing the Bezier curve, how you'll get the flag you see. Now, here you can see, this is the all are individual Bezier curve. And the next Bezier curve I am getting of the similar nature by translating it downward. And that will be implemented in the program. And even these are all number of Bezier curves by just translating it. And then we'll change the color. Then we'll change the color of the curve. Color changing is very simple, you know very well. And therefore change the color. And all this you are seeing, the Bezier curves here, are exactly similar, only the translation has happened. Now, if we can, width of the line, if we can make it bigger, then one will overlap with the others. Therefore, here you can see we'll get with this we'll get completely a rectangular of red segment, and next we'll get the green segment, and therefore next will be we'll get the blue segment. Therefore, I have just RGB color I have taken, and therefore these 3 colors can be given. And that line you are seeing, this is just a straight line with your required width. And this is the concept of this program. And how the animations are done, that is also, I'll say that animation is done by changing the control points itself. Changing the control points itself, that will show in the program how to change the control points. And if the control points are changed, then the shape of the Bezier curve also change. That means we will be changing the location of the control points, and how the location of the control point will change, that I'll discuss when I'll discuss the program. Now we'll discuss the implementation of animated flag using the Bezier curve in C language. Now see, these first two lines are the header files, and you can see one variable animation that will be used to choose the menu options. And next we are a structure has been created, and the members are X, Y, Z. These are the coordinates values, and in that way we are creating a new data type, and that will be used in the program. Next, you see, this is a function who will be calculating the binomial coefficient. In this function we have two argument. One is n, another is bino, which is array, and that size of the array will declare in the dynamically. Therefore, we are using as a pointer. And in this for loop, outer for loops, you can see k varies from 0 to n. In that way, we'll be finding the binomial coefficient for each values of k starting from 0. And in these for loops, you can see I have shown here in the comments, and that we are finding factorial n divided by factorial k. Next, you can see in this for loop, by dividing by j, which j varies from n minus k to 2. Here we are dividing it by n minus k, and that way in this complete that functions, we are calculating the binomial coefficient for each values of k. Now we'll discuss about another function, compute Bezier point. This function will find a single point on the Bezier curve for a particular value of u, and therefore we, as an argument, we have to get an u, and this is the Bezier point that to be calculated, and we require a number of control points. We require the control points itself, and we require the binomial coefficient as an argument. And here n is equal to number of control points minus 1, and we are declaring a variable Bezier functions, and the Bezier points we are initializing with 0. Now you can see here Bezier function is calculated. You know that from the Bezier equation formula, it is multiplied by the binomial coefficient and u to the power of k, and multiplied by 1 minus u to the power n minus k. And Bezier, after calculating the Bezier functions, we can find the coordinates of the Bezier points. The first x coordinate and the y coordinate, and then z coordinate. And these Bezier functions will be multiplied by the corresponding control points coordinates, and that will be summed up. And it is in the, if you refer to the Bezier equation, you will see that it is a summation. Therefore, there is a loop is required to make the summations, and that is all about this function. Now we'll discuss another function, plot Bezier points. In that function, the points will be plotting on the curve, and for that purpose we'll get each point by calling a function which is discussed earlier, compute Bezier point, and will be give the value of u from this function. Now you can see we have here a Bezier curve points. We have created that variable, and that we have, and for binomial coefficient values, we have created a dynamic memory allocations we have created. And after dynamic memory allocation we have created, we are calling that function to get the binomial coefficient. After getting the binomial coefficient, you can see here we are computing the value of u. Computing the value of u, how you are calculating, and that is the k divided by number of Bezier curve points we want on the curve. Now here it's very important to mention here that we are keeping the value of z coordinate as 0. Therefore, our curve will be drawn on the xy plane. Therefore, z coordinate we are not considering. Therefore, here only the x and y coordinate is plotted and z coordinate is 0. Therefore, after this function compute Bezier points is called with the respective arguments. It will be returned. The Bezier points will be returned, and that point is plotted, and we draw the lines. And each is very near. Each point will be very near to each other, and the line will be joining to each other. And in that way, we'll get the Bezier curve. And that is all about this function. Now we'll discuss the display function. Here, with the help of the Bezier curve, we'll draw the flag. Now how it has been drawn, we'll discuss here. Now here you can see we are taking the number of control point is 4, and number of points on a particular Bezier curve is 30. And here theta is initialized with 0, that is for animation purpose. And here these are the control points. You can see the first control point, the x coordinate is 100, and next control point is incremented by 80, and similarly all are getting incremented by 80. But the y coordinate, you can see the first is 410, next is incremented by 60, but here it becomes 350. That means it is decremented by 60. And the fourth control points, the y coordinate and the first control point y coordinate is remain the same. In that way, it is like similar to a sinusoidal curve will get it. And very importantly, here you can see the z coordinate of all are 0, and therefore we are plotting the Bezier curve on the xy plane. And that is an important thing because z coordinate is 0. And now this is for animation purpose we'll discuss slightly later on. And then first we'll draw the flag. How to draw the flag, that we'll discuss. Now we come to that and how to draw the flag. Now each point will be drawn with the size of 5, and each line width will be whatever the line width will draw is 5. That means a bit thick. Now here you can see the push matrix. Why it is required? It is important to understand why push matrix is required. All the Bezier curve will be drawn. Matrix will be changed, and that matrix will be kept into the stack. And then with the pop operation, that it will be drawn. It will be drawn all the Bezier curve together. Why it is required? Because during animation, every time this display function will be called, and if it is not kept into the stack, then the matrix informations will remain the same, and therefore every time it will enter into the display, the matrix informations will be stored into the stack. That is required. Otherwise, animation will not happen. Any Bezier curve we can draw, but the animation will not happen. Now you can see that first we are giving here it is a saffron color, and here you can see we are translating by minus, that means negative of y direction 1.8, and then we are plotting the one Bezier curve, and that type we are rotating it for 25 times. There were 25 Bezier curve will be drawn, and each time it will be translated in the negative direction of y. As a result, the 25 Bezier curve will be overlapping each other, and it will give a rectangular saffron segment. And exactly in the similar way, we are changing the color to white now, and again there will be a 25 Bezier curve will be there in this, and every time it will be translated by minus in the y direction minus 1.8, and together all this 25 will be overlapping each other, and it will give a rectangular white segment. And exactly in the similarly where here also we are changing the color to green, and then we are translating, and by minus 1.8 and 25 curves will give a rectangular segment of green. In that way, there are 3 segment of color will be there, but the individual Bezier curve will not be seen. And then will pop the matrix, and the actually Bezier curve will be drawn. After that, the stick, that means where the flag will be which stick will be holding the flag. That is just a line, and that will be the that is we are showing here. And here it is very important to mention here, this is required for this post display is required for animation purpose. Now I'm going back how the animation is happening. Now I'm going back to how the already I told here animation is happening. Here you can see the first control point we are not touching. This is the second control point. Second control point x and x coordinate we are changing by sinusoidal. Why sinusoidal? Because sine varies from 1 to -1. Therefore theta we are changing the theta, and therefore this function will be changing, will be from -1 to 1. It will be value will be from -1 to 1. As a result, you can see the that x coordinate of the control point will be changing. Exactly similarly, y coordinate will be also changing. We are changing the control points coordinates, and therefore here in the similarly for the second control point also, similarly third control point also. But another thing has to be mentioned, why we have changed the theta plus 40, theta plus 50. That is nothing but we are not keeping all these in the same phase. If we keep in the same phase, this wave will be of very systematic manner. But when a flag will be waved, that it is a randomly it will wave. Therefore it will so that for that we'll keeping the different phase for different control points, and that is the things. And now you can see here. Now we can see here we can here animations. If we can do the animation also, we can without animation also. Therefore, if in the menu if we choose the and with animation, therefore this is the two will be chosen. Therefore, we'll show it here and show it here, and this is the initial function. Initial function. Therefore here we are declaring the background color, and this is the size, and this is the size of the display. That now you can see the another function. Therefore if we are choosing the with animation, then two will be chosen, and without animation is 1. Therefore where it is, you can see here, this is here in the here it is 1 for without animations, and with animations with 2. And this is the menu creating, and therefore I am showing you again. Again the complete display function again. Now this is the starting of the display functions. Now this is the control points are declared. Here is the for animation purpose. Next is the that already I told that Bezier curves are drawn here. Bezier curves are drawn here. Already I discussed it, and therefore this is the complete display functions. After the display functions, that is another function is init, and here we are initializing the background color, and the matrix mode is projection, and we are choosing the display area. We are ortho 2D, glue ortho 2D, and after that this is the menu. If the option 1 is chosen, then this is a without animation. 2 is for with animations, and this is the main functions. Here at the main function, size of the windows we are creating, name of the windows, and this is for creating the menu here. This is the creating the menu here, and that is all about this implementation of animated flag using the Bezier curve. Now we'll show the implementation of menu driven animated flag using the Bezier curves in code block. Now first you can see here I have created a project with flag Bezier 1 in the code block. In that project I have included a C file Bez flag1.c, and in that C file I have typed whatever the code I have shown. I have typed exactly the same code, and then I want to built it, and then I run it. And you can see a flag appears. A flag appears, and that first segment, top segment of the flag is a saffron color. And in that saffron segment, there are 25 Bezier curves are there. And each Bezier curves exactly of the same shape, but it is been translated slightly in the downward direction, that means negative direction of y. And these 25 Bezier curves are overlapping each other. Therefore, each individual Bezier curves are not visible here. And that 25 Bezier curves, due to overlapping, it creates a saffron segment. After that, we change the color of each Bezier curve, and that the another 25 Bezier curves are producing that white segment. Exactly in the similar way that another 25, after changing the color, is creating the green segment. And therefore, these are the way and how the flag is being generated. And then this is the stick, and this is just a straight line, and with a line width of 5, and which you can choose the color. And then I'll just right click here, and then you can see the menu appears, and there are two options in the menu, flag without animation and flag with animation. I choose the with animation. That animation is happening now. And now if we want to stop, and then we choose the without animation, the flag will stop here. And that is about the output. That is about the output of this program. Now I want to discuss some points in the program. Now you can see that this is the program. I typed it, and this is the already I told this is the header file. This is the you can see this is the structure. In that there are 3 variables, 3 members in that structure, and this is we are creating a user data types, and it is the COEFF. This is the function. We are calculating the binomial coefficient that I discussed also. And now we are another function, compute Bezier points. In that we are finding one point on the curve, and that point we are calculating here. That also I discussed. And this function will be called from plot Bezier points 30 times, because we are using 30 points on a particular Bezier curve. 30 times it will be called, and these 30 points will be called with a different value of u, and that u is calculated here, and after calculating u, we are calling the compute Bezier points, and in that Bezier curves is drawn. After the Bezier point is returned, we are drawing the Bezier curves by these functions, and we are joining this every point with a straight lines. Another point we mentioned here already I discussed about that because we are using the pointer for bino, and therefore it is an array, and therefore you are using a malloc function for dynamically allocating the memory location. After that, we are calling that binocop function for binomial coefficient to keep the values in the memory locations. And that is all about this function. Then we'll discuss the display function. Now we'll discuss the display function. In the display function, you can see there are 4 control points, and there are 30 points in each Bezier curves. And after that, you can see we are declaring the coordinate of the control points, and and the z coordinates you can see all are 0. Therefore, we are plotting the Bezier curve in the xy plane that I mentioned earlier also, and that is an important thing also. And now you can see all the sine function here. That is all this due to this is for animation purpose that I'll discuss now. The first thing I wanted to tell you that this display function will be called again and again by another function, and this is called glut post redisplay, and that is the function which is responsible for calling the display functions again and again. Actually, it is calling the current current window, but it is the display function itself is the current, it is responsible for current. Therefore display function will be called again and again. Now you can see here, one thing I have to show here, if you, this is the main, if you make it is a comment here, and then you can see again you built it, and again you run it, and then you go for an animation. With animation is not happening. Therefore you can see that is the function which is mainly responsible for animation, because this function will be calling the display function again. If the display function will be calling again and again, what happens, that I am going to discuss. Now when the display function will be called again and again, you can see the x coordinate and y coordinate of the second, third and fourth control points are changing, but the first control point are not changing, because the first control point will be attached to the stick, the holding stick of the flag. Their first control point is not to be changed. Therefore, but second, third and fourth control point will be changing, and sine function varies from -1 to 1, and therefore the every time that it will be a display function will be called, the x coordinate, y coordinate will be changing if the theta changes, and therefore theta will be changing if the animation is equal to 2. You can see here theta is changing if the animation is equal to 2. That means if we select the option in the menu that with animation, then only theta will change. As the theta will be changing, our x coordinate, y coordinate of the control point will be changed. As the control point will be changing, shape of the Bezier curve will be changing. Therefore at one time the Bezier curve will become flattened, and therefore flag also will become flattened. And in that way, if these things will happen very fast, it will appear that the flag is waving. That means flag is waving, and because flag is waving, it will appear because of the change of the Bezier curves, and that change is happening because of the change of the control points, and these are the control points. And these control point, again I repeat, these control points are changing because when you select that with animation, and theta will be every time the display function will be called, theta will be changing by 0.2, and as a result that x and y coordinate will be changing, and the Bezier curve will be changing, and it will appear to be animated flag. And that is the fundamentals of animations. And then another important point I wanted to tell here, another thing you can see, static. Theta should be a static, because static meaning is that theta will be initialized only 1. Every time the display function will be called, theta value will not be initialized again and again. Therefore you can see here, if we delete that static, and then if you build it again, you will get a flag, but if you go for a with animation is not happening. Now therefore we have to give the static, static here, and that is the thing again, and this is all about. And another thing I have to mention here, therefore you can see the push matrix and there is pop matrix. These are also very important in this case, because the transformation matrix has to be kept into the stack, because if you do not keep into the stack, the transformation matrix will continue to change. As a result, if you delete that push matrix and the pop matrix, then because of continuous translation of the Bezier curves, that it will go downward, and ultimately that your screen will be blank screen. That means black screen it will appear, and that will happen. Therefore every time the display function will be called, the transformation matrix should be kept into the stack. That is another important point. And here we can see another thing I have to show you, that we are creating a menu here, and you can see that add menu entry. Therefore we have associated 1 with the flag without animation, and 2 with animations. And if you right click, then only the menu will appear, and that we have done it here. And therefore, again, I just show you in slide in details that this is the display function, and display function, this is the control point, this is the associated with the animation. Therefore, here if you choose the animation, if you choose the animation with animation, then theta will be changing, otherwise theta will not be changing, and that is we have done here. And then we are with given a color and 25 Bezier curves we are giving here, and this 25 Bezier curve will be overlapping with each other, creating the saffron segment. Then another 25 will be creating the white segment, and then another 25 will create the green segment, and then we'll draw the stick here. We'll draw the stick here, and now post glad redisplay, it will call the display function again and again, and in that way that animation is happening, and then I'll show the output. Last time again we will build it again, we will run it, and with animation we'll do it. You see this is the animation is happening. This is all about the implementation of menu driven animated flag using the Bezier curve. And thank you for listening.